Assalamualaikum warahmatullahi wabarakatuh. I, Daniel Faris, and with my group mates, Muhammad Shahir, Nurul Fatina, and Sarah Amanda, shall present about the exponential function in investment. Now, first off, let's begin with the introduction.
The introduction of exponential function is that it's an important class of non-linear function that is of particular interest in economics comprised of the exponential and logarithm functions. These functions are useful for investigating problems associated with economic growth and decay and mathematical problems in finance such as the compounding of interest on an investment or the depreciation of an asset. Investment expenditures. Investment expenditures is the smallest and the least stable component of GNP. There are two categories of investment expenditures. One of is planned investment, which is anticipated or intended investment. Planned investment is the investment expenditure the business firm would like to make over a period of time based on the condition of the economy. It includes the amount of new plant, equipment, and housing acquired during the year and in addition to inventories which business want to acquire. The second is realized investment, which is actual investment. It is the investment expenditure that the business actually make over a period of time. The quantity which show up in the official national products always include all investment in plant, equipment, housing, and inventories, whether that investment is desired or not. The difference between planned investment and realized investment is called unplanned change in inventories or investment. Unplanned investment or undesired inventory accumulation are products that remain unsold. It's stocked up on retailers' shelf and in warehouse.
Investment and interest rate. Interest rate is a charge imposed for the use of borrowed funds over a period of time. It affects the cost of investment. As interest rate increase, the cost of borrowing will be higher, hence the cost of making the investment will be higher. Consequently, investment will decrease and vice versa. The relationship between interest rate and investment is negative. Interest rate is also influence business in terms of earning a higher return on the money or funds that they place in the financial market. A higher interest rate will motivate business to place their money in the bank to earn higher return, therefore discourage them from using the money in making investment purpose. A lower rate of interest will cause business to spend their money in making investment which they anticipate to give a higher return on investment compared to the low interest rate. What is compound interest? Compound interest or compounding interest is interest calculated on the initial principal and also on the accumulated interest of previous periods of a deposit or a loan. Thought to have originated in 7th century Italy, compound interest can be thought of as an interest on interest and will make a sum grow faster at a rate than simple interest, which is calculated on the principal amount. The rate of which compound interest occurs depends on the frequency of compounding. The higher the compounding number of compounding periods, the greater the compound interest. Thus, the amount of compound interest occurs on a $100 compound at 10% annually will be lower than that on $100 compounded at 5% semi-annually over the same time period. Compound interest is calculated by multiplying the principal amount by 1 plus the annual interest rate raised to the number of compound periods minus 1. The total initial amount of loans is then subtracted from the resulting value. The formula for calculating compound interest is compound interest equals total amount of principal and interest in future or future value less principal amount at present or present value. Take a 3-year loan of 10,000 at an interest rate of 5% that compounds annually. What would be the amount of interest? In this case, it would be 10,000 times the product of 1 plus 0.05 to the power of 3 minus with 1, which is equal to 10,000 times 1.157625 minus 1, which is equal to 1576.25 dollar. Now, when an investment B follows an exponential growth model with a fixed rate per period, say a period of 1 year, the investment model with respect to the time is written as annual interest rate. Yearly exponential growth model, i.e. interest, is applied at a fixed percent rate at the end of each year. BT equals to B naught times the product of 1 plus R to the power of T, where BT is the balance at time T, year, and B naught is the initial investment amount, and R is the decimal equivalent of the yearly percent rate. Whenever the interest or rate of growth per period is yearly, we can call that the annual rate or nominal rate. Next, compounding greater than a yearly. If n is defined as the number of periods in a year, then we define periodic compounding as BT is equal to B naught times the product of 1 plus R over N to the power of NT, where BT is the balance at time T, year, and B naught is the initial investment amount, and R is the decimal equivalent of the yearly percent rate. Example compounding is monthly, N is equal to 12, quarterly, N is equal to 4, daily, N is equal to 365. Continuous compounding. When the number of compounding per yearly is large, even greater than hourly, where 365 times 24 is equal to 8,760, we define this as continuous compounding. BT equal to B naught times E to the power of RT, where BT is the balance at time T, year, B naught is the initial investment amount, and R is the decimal equivalent of the yearly percent rate. With all these various types of compounding, one often needs to evaluate each compounding as it compares to the yearly compounding interest rate. We call this normalization the effective annual rate. The effective annual rate is found by setting the various compounding equals to each other and finding the equivalent to the yearly rate of R from 1 plus R.
Now we know that compound interest has three types, which is number one is the annual interest rate, the second one is the compounding greater than yearly, and the third one is continuously compounded interest. But how does it grow? Okay, compound interest also takes into consideration accumulated interest of previous years. The amount interest for all 3 years is not the same as it would be with single interest. So let's see at the table here. Okay, let's say for year 1, the opening balance is 10,000 ringgit and the interest is at 5%, which is 500 ringgit, and the closing balance for the end of the year will be 10,500 ringgit. For the second year, the opening balance will be the value of the closing balance for year 1, which is 10,005 ringgit. understanding the time value of money and the exponential growth created by compounding is essential for investors who are looking to optimize their wealth and income. As money is not free, it has a cost in terms of interest payable, where it follows the concept that $1 today is worth more than $1 in the future. This concept is known as the time value of money, which forms the basis of more advanced techniques like discounted cash flow analysis. The opposite of compounding is called discounting. It is the discount factor, where it is the reciprocal of the interest rate. The formula for obtaining the future value, FV, and the present value is given by FV is equals to PV in the bracket of 1 plus I over n to the power of nt. For example, finding the future value of $10,000 compounded at 5% annually for 3 years, where $10,000 is equal to the present value and 5% is equal to I over n, where 3 years is equal to nt. The future value is equal to $11,576. Next is finding the present value of $11,576 and 25 cents discounted at 1% for 3 years. The PE, present value, is equal to FV given by $11,576.25 divided by 1 plus 0.05 to the power of 3, where you will get back 10,000, which is the future value. This figure shows the investment demand curve, where the amount of investment increases while the interest rate increases. However, there is some factors that could affect the investment demand curve other than the interest rate. This factor is called the determinants of investment, which will be further on discussed. In conclusion, the exponential function has a big role in the investment in business. By doing this project, we learned that mathematics expresses itself everywhere, especially in economics. In economics, exponential functions are useful to look at the growth or decay as such an investment rate that increases by a certain constant percentage. Furthermore, while plotting the graph of exponential function, we realize that as the value of x increases, the value of y increases or decreases rapidly. These characteristics enable us to use exponential function regarding calculation in investment. Overall, in this research, we can see that exponential function plays a big role in economics and social benefits. Thus, we as students should study more subtopics related to economics in mathematics. Furthermore, there will be no questionnaire on why students should study maths, because it is clearly crucial for the better future.
Okay, so as Muslim, we should know what we do is halal or haram. So in this case, we talk about the compound interest. So this is one of the verse on absolute prohibition of simple and compound interest. In the Quran, Allah said that, "O believers, fear God and give up the interest that remains outstanding, whether it is simple interest or multiplied interest, if you are believers." Surah Al-Baqarah, verse 278. So this verse commands us to abandon the amount of riba and directs that only the principal amount should be paid and nothing in excess, because any amount in excess of the principal fixed in the contract of the loan is called riba and nasi'ah. So any kind of riba is haram, so we should take for granted.